Chapter 9, What Counts as a Design Solution? Chapter 9 is really about the attitude or posture an engineer should take towards his or her design solutions. So in Chapter 8, we discussed harms and unprovoked harms, and so how our design solutions can cause harm even when they don't provoke harm. In Chapter 9, what's really being argued for is an attitude that you as an engineer ought to take toward design solutions. So what Chapter 9 argues is that what counts as a design solution ought to be thought of as tentative. That is, that whenever we come up with a solution to a problem, we should never view that solution as something that's permanent. It should be thought that we can always, no matter how good the design is, so while we may be striving for the best design, that we can always do better. So when we're looking at design solutions, we should be thinking that while this solution may be good, and it may have gone for the best possible solution, there's always room for improvement. There's always something more we could have done to make the design better. And that really is not so much about morality, although one could argue that it is about what an engineer's obligations are or duties are as an engineer. But in many ways, it's an attitude. It's a moral attitude we take towards the work that we do as engineers. So there's a few examples. As your book notes, there's the road stripes example. And the road stripes example is an example of a poor design or a poor solution to a problem. So the new road stripes were intended to decrease accidents. There's a description of the off-ramp and how initially the off-ramp there were accidents, and so there was the idea that if we rerouted traffic, if we drew new stripes, we could avoid these problems. And what ended up happening was that the solution actually ended up causing more harm. So the idea that the solution actually worked didn't turn out that way. They thought it was going to, and this is an example of how things could have been done better. So the idea that when the engineers look at this, you would reevaluate what it is you did. And so the road stripes example is really just meant to show how things can go very badly, how a solution can be a bad solution. But the clear view, the font example, is another example of how design can go wrong in sign fonts, but it also shows how things can be done right, or the right attitude towards design. So the Clearview font was one that was developed over 10 years. Right, and so it was meant to replace the highway Gothic signs that came before it. And this is a good example of the tentative or iterative design sort of process. So we look at Highway Gothic widely used not only in the United States but overseas. And it turns out that it wasn't the best font for highways and roads, that there were visibility issues, there were issues with visibility for seniors and for older people or people without perfect vision. And so over the course of many years, of 10 years as I mentioned, the font was refined and refined. It was tested and then retested, and then a new font, and changes were made, and letters were made thinner in the fonts, and there were more space put in certain of the font letters. So for example, the E or the A around the circle. And what this just demonstrates is that even when we think we've got something, even when we think we've done something better, so you'll notice on the right here, the Clearview 1W, 2W, 3W, and so forth. Each of these were an improvement over the previous Highway Gothic font. So you can see Clearview 1 versus Highway Series B. That's a little bit better. It's more readable. It's easier to see. And then 2 is an improvement on 1, and 3 is an improvement on 2, and so forth and so on. So this just shows that when you're engineering, whether you're engineering a font or whether you're engineering something else, that there's always room for improvement. And really, again, that's an attitude, because sometimes we think we've got it right. And this is true of not just engineers, but anyone. Writers think they have it right. Philosophers think we get it right. But there's always room for improvement. And this is the sort of attitude that Chapter 9 wants you to take as an engineer. So what do these examples show? Well, it shows that design solutions are contingent choices. In other words, we shouldn't view a design solution as ever being a permanent solution. So designs change over time. Design solutions are context dependent. So we want to keep in mind that while you may be an individual or a team, that designs occur at a certain time in history. And not only do they occur in times, but they occur in particular places. And They occur by specific individuals that impart their own values to a design solution. So time, place, and the person or team doing the design are all contingent. As time passes, as needs change, as conditions change, the designs need to change. And so this is the idea that you take the attitude or the posture that the solution you're going for should be more than the minimum, as we've mentioned in the past, that engineers shouldn't strive for the minimum requirements or the minimum safety, but we should look for the best design. But at the same time, we should recognize that no matter how well a design may be, no matter how well our solution may be to a problem, it's going to be time, place, and person or team dependent. And that's going to reflect the values of that time, of the place, and of the person or team that's doing the design solution. So again, you can see how this is an attitude, but also we want to recognize that the attitude we take has moral implication. Because as an engineer, it's not just that my writing is time dependent or place dependent, and obviously person dependent. It's not something that I put it down in a book and perhaps people read it later, perhaps they don't. With an engineer, my activities are such that I can do real harm if I'm not aware of this, or if I don't at least view the design as something that can be improved upon. So there is that moral element. So ethical choices embodied in design choices. So this is sort of now taking the three parts that we've already talked about. So engineers should always keep use in mind. So the defibrillator example, how is my design going to be used? In what context will it be used? Engineers should keep in mind the environmental sustainability. So this is from the previous chapter 8 where we're talking about harms, not only provoked harms, which we obviously are going to avoid, but also those sorts of harms we might not think about. Environmental sustainability in terms of recyclability, reusability, repairability, all of those things should be kept in mind with any design choice or solution. And as Chapter 9 is trying to emphasize, we should take the point of view or the position or the attitude that designs can always be better than they are. So really this is the main point that Chapter 9 is making, is that we should take an attitude, and there is a moral component, a value component to this attitude, because as we design things as engineers, as we work on projects, we want to keep in mind that no matter how good our design is, we should always be saying, how can I make this better? That's sort of our moral obligation to be a good engineer, to be the best engineer one can be. This is the sort of attitude we should take towards our design solutions.